Hello, everyone, and welcome to our webinar on object storage for developers. My name is Adrian Herrera. I'm the VP of Marketing. I'll be the moderator today. First, before we start, a little housekeeping. You could go ahead and ask questions throughout the webinar, and the presenter, who I'll present in a bit, will answer them or try to answer them. If he doesn't get to them during the webinar, there will be a short Q&A session after, and we can also follow up with you directly. Our presenter today is Ryan Meek, a product manager for Caringo. Ryan, say hi to everyone.
Hello, everyone. Glad to be with you this morning.
And with that, I'll just kick it off to you to get started.
Great. Thanks, Adrian. Appreciate that. We have a great presentation for you this morning. We're really excited to be here. And we were joking earlier that it is information rich. We are not going to hit you with a big marketing presentation, but I did want to share real special information for developers and about object storage in general. So as a quick introduction to object storage, you know, objects are the basic encapsulation of data and metadata. And this is a key thing about these systems. These objects have a chance to be self-describing so that they can be made relevant to the environments that they're in. And one of the key ways and one of the key aspects of object storage in general that makes it important and relevant to applications is you really get a chance for the data protection, the high availability, and the high performance to be built in at the system level. You know, in a lot of cases when you're writing an application, you're relying on either file systems or databases or some other system that wasn't necessarily built for high availability from the ground up. And so with object storage, you really get that. You get it for a lot of reasons. You know, data protection, you especially get it because when the metadata and the data is co-resident, you get a chance to integrity check the metadata and the data together. You get high availability because the entire system is designed so that if any one aspect of it goes down, the other aspects are available, whether that's on-premise or whether that's at a DR location. And high performance is also built in, especially because these systems tend to be eventually consistent instead of strongly consistent. You know, one of the big things that slows down applications, especially at scale, is locking or distributed locking. And eventually consistent systems have a chance to be high performance by their very nature, where all the nodes in the system or all the servers in the system can handle high performance read-write loads. So the front end is typically HTTP, and this facilitates these aspects in quite a few ways. HTTP itself gives you location independence. So not only is the application location independent, so you know it can find, for instance, a web target, whether it's on-premise or whether it's in the cloud. It can be written with sort of this high availability and this location independence built in, but it gives you the transaction encapsulation so that if there's any issue with a transaction to either one server or one location, you can transparently redirect that transaction to another server in another location. So this is really disaster protection, high availability, data protection, and high performance all built in. This is a key aspect of object storage. And all these things make it ideal for cloud storage. So when people think about, okay, well, what are the value props for cloud storage? All these same reasons that object storage is great for applications makes it a great backend for cloud storage. So a little bit more about HTTP in general. These HTTP front ends tend to be RESTful. They tend to be, you know, the basic HTTP verbs. You know, in our case and in many cases, it's post, put, get, head, delete. And sometimes, those can be extended, but those are the basic sets. Typically systems have their own API. I would say the de facto cloud standard in the world right now, or at least the most common one that's implemented out there, is S3, and many object systems will implement their own S3 protocol. Many applications now are written so that although S3 is the protocol, they can be pointed at other arbitrary S3-enabled targets. And so, so you get, with HTTP, you get the location independence, you get the transaction mechanisms. It's also the most commonly used language in the world, really, for online aspects, online transactions, and online content. So there are implementations of HTTP in every language, or every relevant computer language out there. You can, pick up whatever new language you're looking at, and there will be an HTTP library that will facilitate development to these systems. It also ends up being a very natural place to take advantage of features of object systems when you can include information in metadata and in the headers. So if you're looking at object systems in general, one of the things to look for is object systems that facilitate data protection, high availability, or even data protection strategies like erasure coding, replication, and things like write once, read many, policy management, right in the headers and right in the metadata. So once you have that HTTP protocol, and once that's well specified, one way to sort of approach the documentation and implementation challenge for developers in the field is following a specification, using a HTTP library in your favorite language to write to a system. And what we've found along the way is that people would ask us, okay, well, that's all nice, but do you have code samples, or do you have best practices or recommendations for implementing those APIs? So what we've done at Caringo, and I think what best of breed object stores have also done, is include software development kits that actually implement that REST API. So look for in general these APIs or the implementations of the APIs and the SDKs to be open source, or at least source provided. In many cases, or in some cases, they have been proprietary libraries, and that actually ties client applications into proprietary code stacks. So I would just caution people against that in general. We use open source and source provided, and we wrap the industry standard, best HTTP libraries with our own best practices. So, in the Java case, it's an Apache Commons client. In .NET, it's careful usage of the .NET provided HTTP and TCP libraries. In Python, it's the embedded class, it's the standard classes. And similar in C++. So, we aren't always implementing from the ground up. Many times we're taking advantage of, really mature and really well utilized HTTP libraries. Even these sometimes have issues buried inside them. And so I think a real best practice is to actually take advantage of the software development kit, which may either work around or facilitate perfect connection pooling and perfect sockets reuse when that can be left a little bit vague by the underlying libraries. The other thing that you get from software development kits, ours in particular, is you get high performance throughput, connection pooling. These are sort of best practices. It's set up for multi-threading when you want hundreds or thousands of transactions a second, you really need an optimal implementation, and we guarantee that, through QA of every release, as you would sort of expect. So what are development best practices? So we especially recommend long-lived client objects, and it might not be for an obvious reason. So if you're thinking about, okay, well, if when I'm actually down there coding, how do I use a library? Do I set up a new client for each transaction or each file? Or do I set up a client and then run multiple calls through that client? And we really strongly recommend long-lived client objects, in particular because that allows a persistent connection pool to keep open HTTP connections to multiple nodes at the same time. Then these connections can be reused, and the overhead for setting up and tearing down sockets can be conserved on the client and on the server side. We also, strongly recommend client-side logging be set up, in your application so that this logging level can be changed at runtime. One of the things that you see when you get into production systems, and if there's behavior that's either unclear or if there's some kind of issue being seen, is being able to elevate the client-side logging level makes troubleshooting those issues much easier if you don't have to restart the clients. So these facilities are provided by underlying libraries like Log4j, but we strongly recommend using them. If you're in a hospital or if you're in a mission critical situation and you need quick answers, you often do not have the luxury of taking the system down and bringing it back up with a different level. So, strongly recommend client-side logging. And if you have access to server logs during development, we strongly recommend that as an extra check. Client-side logging should be plenty. HTTP response codes give quite a bit of information. You can tell whether your connections are being completely serviced or being closed incompletely. But on the server-side logs, you get to see even more information about, say, whether a particular transaction had any unintended consequences. So in our case, we make actual server code available to developers, and I think I would look for that in general if I were reviewing, object storage systems. In our case, that's available through Caringo Connect, and we're happy to provide that help along the way. Another sort of best practice for development is what we'll introduce here, and we'll go a little bit more into. And we call it locator strategies, and this really goes back to high performance and high availability, and specifically high availability across different sites. So, one aspect of a locator is when an application starts up, how does it get access to the first few nodes? So in many cases, this is a static list of IP addresses, but it can also be things like DNS names and zeroconf bonjour service discovery. So I'll just move forward here, and we can get a little bit more into why that matters. So in the locator strategies in general, the bonjour zeroconf way of discovering nodes is really similar to finding a printer. So this is especially nice for service-oriented architectures where you want to insulate the client so that it can start up on a network anywhere it actually has service level discovery for those clusters. So you can configure your client to say, pop up and say, can you find a cluster named this? If so, where are the nodes? And it'll get a list of those nodes back and you can address them. So that gives you many different nodes at the local site. So that's, high availability right there. The other aspect is, if you put a cluster behind a DNS name so that those IP addresses will end up being routed to those servers, that's full location, high availability, and disaster recovery built right into the application, which is tremendously powerful. Okay, so from those best practices, how does that connect to use cases in the field and customer integrations? What features from the SDK and from the API specifically matter to customer use cases? So cultural archive is an especially interesting case, and it's a case that we have deep experience in from really the early days. I think a cultural archive may have been one of the very first instances at Caringo, and I think in general. And it's a few different reasons. One of them goes back to data protection, and in our case, integrity checks and integrity seals allow the validation of metadata and data. So metadata and data is, co-resident and encapsulated and continuously validated through background checks. This content can be really clearly validated going forward for years and years. These checks persist with the objects across multiple servers, across multiple sites, across any new hardware that's introduced. And it's especially important to consider that when it's a go-forward content collection of either national importance or cultural importance. This needs to be a solution and a strategy that you can add hardware to in the future, and the content sort of flows into. That needs to be transparent, and the data protection needs to move along with it. In our case specifically, that goes to hashing strategies or integrity seals. It's probably not as important for, more advanced hashing strategies yet, but we'll get into that later. So compliance archive, advanced hashing probably is more important. And compliance archive, I would really think of as more like banks and keeping check images, for instance. So this has a compliance angle. It's important for the content to be validated. It's important for the content to be clearly identified either in a court of law or so there's no ambiguity. And it may be also, there may be incentives to tamper with the data. So hashes that are easier to break, like MD5, you may look for systems that can incorporate hashes that are much stronger. We call that integrity seals at Caringo, and it's a really nice future-proofing mechanism against whichever hashing strategy will get broken next. So digital evidence is also related, and I think what's added there that's really important is high performance and video streaming. So from a developer perspective, once you get into digital evidence, this is really a hot topic right now. It's getting a ton of funding from police departments. We have some deep experience in it. From a developer's perspective, you can stream video from HTML5 directly off servers, and you can use an object storage cluster as a backend for a video archive that people can actually, view the videos directly. They can use the progress bars. And one of the things that we've done and that you should look for in general is object storage systems that can serve range reads or HTTP range requests. This just makes it, very responsive for an end user. So digital evidence systems in general they're going to be high scale, they need to be high throughput. I would say the other thing there that's important is strong custom metadata as well. So you may have a video or you may have a photograph, but it's especially important to include metadata or custom metadata about everything you know about that image or everything you know about that video, so that it can be indexed for search later and findable by a user. So whereas compliance archive may be something more like for a bank or for a trading house, there may be a user needs to be able to find something, but it's not necessarily that important that they can search through a video or that they can cut through an entire time sequence of videos. And then I think that those value props sort of feed into content delivery in general. So object storage is an ideal backend for web content delivery, and that's really what we mean by content delivery here. I don't think we would be referring to any other kind of content delivery. It needs to work at scale. You need to be able to handle petabytes of data. It needs to be 24/7 uptime. And one of the really interesting aspects of an object system for content delivery is, many of the old content delivery cases were a SAN or a NAS combined with a layer of web servers and a layer of load balancers and databases in between. So that is quite a few layers of things that can go wrong, and the end result is you are serving content to the web. Well, an object system serves content to the web inherently, especially if they are purpose-built devices and object storage provided at the system level all the way down. That one thing to get into here, it's a bit of a tangent, but I know my audience is pretty savvy here. Object storage can be provided at the interface level, the system level, or the device level. Now, if it's just at the interface level where someone has an API and they call it object storage, well, it could still be databases and file systems and things that weren't designed to scale easily or be high performance. And so when you use a system that was built from the ground up for this purpose, those layers have been collapsed. So you have one layer that you can scale up on demand. That's a much more simple and dependable way to scale than having layers of web servers, layers of databases, and layers of SANs and NAS. So real finally, I wanted to make sure and cover also, we didn't put it on the slide, but you're going to hear, if you're not already, the term data lake quite a bit in the market. And in many cases now, a big aspect of the data lake is Hadoop or HDFS. Now, this is a huge movement in data processing and data calculation, and there is quite a bit of data in these systems. We see it being really poorly regulated, or at least it's a bit of the wild, wild west in the IT shops, and we see quite a bit of data growth there. And in most cases, the data protection is three replicas, and so that can be 3 replicas on the primary site plus 3 replicas on a DR site, even if they have one. And in many cases, they don't have one. So one of the big use cases that we see for object storage in general, and for Swarm in particular, is a much more efficient footprint and long-term archive for big data. So instead of, say, 200% data overhead for data protection, because the data protection strategy is 3 replicas, you could say use a 10-2 erasure coding strategy, where that's 10 slices of data for 2 slices of parity, and you'd have a 20% overhead for data protection instead of a 200% overhead. So, I mean, an order of magnitude difference for data protection is a much more efficient archive. Our systems and object storage systems in general have thought out the DR system as well, so it's really easy, and in a lot of cases, you can set up a DR cluster with a publish-subscribe relationship to a primary cluster, very simply, and you have a huge value-add benefit there. At the developer level, it interacts with the Hadoop system transparently. If the system has implemented the Hadoop FS interface, which we have, so the Hadoop, say, HDFS, DFS client, you can write files transparently from HDFS to any swarm target, and that's completely transparent. So just moving on, actually covered quite a bit of this in the online content and web tier, but it's really worth going over because web traffic is already HTTP. HTTP is an ideal storage envelope for objects because it is, metadata and data. This is a my message, for instance. It's headers and data, so no protocol changes are necessary. The object storage serves HTTP natively. And you want to look also for systems that have implemented HTTP cache coherency headers so that upstream proxies and web balancers can tell whether content has been updated so that they know they're always serving the most current objects, either of that name or of that version. So that is actually one of the big places that we see a tremendous amount of growth in object storage systems. I think those are the points that are important to look for in object storage systems in general and in Swarm in particular. That's a tremendous value add. So Adrian, I think that wraps up the coverage that I wanted to have over the topics at a high level, and some of that was, of course, at a very low level. And I wanted to throw it back to you and open it up for questions.
Yeah, so for the audience, go ahead and type in your questions in the question dialog box to your right. Ryan, one thing that we didn't do at the introduction of the webinar is give a little background on your experience, why the audience should be listening to you. So can you tell them your background and what you've done at Caringo?
Okay, well, I've been at Caringo either almost 10 years or 10 years, and I started as a developer. I worked on the core product. We had a crazy notion that this was the wave of the future for data storage, and I think that's been completely validated. I think there may be more data in object systems now than outside of object systems. So I started as a developer. I wrote the original samples in the SDK, or the original integration code samples. Those became the SDK. I've done everything from QA to pre-sales, implemented object systems all over the world, and worked with customers and partners on just about every aspect of delivery and support. And it's been quite a ride, so I'm absolutely happy to be here sharing that experience.
Yeah, and Ryan is extremely well respected in the organization. He's worked on deployments, everything from small deployments to web scale deployments to highly secure deployments. So he brings a wealth of knowledge, and this is just an example of the skill set that we have within Caringo. So when you do or are evaluating object storage, feel free to give us a call and we'll walk you through your evaluation. As far as the SDKs are concerned, we're getting a question. What do you have any other SDKs planned than the ones that were displayed?
Those are the ones that we have available right now. We have a few extensions, I think, that I can just tease. We're in talks for a Scala implementation, and we're kind of deciding where to put that on the roadmap. We also have some PowerShell extensions for .NET, looking for a place on the roadmap. So I don't have a date to report or promise, but we certainly have Scala on the mind, and it will hit. We have PowerShell extensions for .NET. We are probably going to implement one in Go, but I think it would be early to tease that. If there is demand for a specific language, we can add it very quickly. We have just seen, most of the interest be for applications around Java and .NET even now. But the time to go from HTTP libraries, which these languages already have, to really an SDK that's usable and implements best practices is extremely quick. So if there's anyone in the audience that really has an application or a project, but they just don't see that language on this list, please get in touch with us and we can see about adding it very quickly.
And as far as the integration time, what's the average time for integration into an application from an object storage perspective? How long does it usually take?
Well, that's a great question. So if someone's starting with an application that's already written for a system, with a database and a file system in the back, the crucial part is to write a data access layer and then an implementation of that data access, for object storage. And so, we've seen that done in weeks. If it's a ground up net new application that's really being written with an eye towards service oriented architectures and using object storage from the beginning, I mean, we've seen those integrations done in a day. Now, of course, developers will laugh at a day because they know that means a day of coding and many days of working through QA and all the systems downstream. So, but in general, I mean, it is a very small interface, and it's small. It keeps it simple. You write objects, you read objects. You can get metadata on objects, and that's all. It's all a fairly narrow and simple interface. So the bar is not high to get started here.
Yeah, and you've been doing this for a long time, Ryan, over 10 years. I mean, have you seen developer acceptance of APIs change over the years?
Oh, completely. I mean, the conversation we used to have was, well, I know where the data is on my network or in my file system. So why would I want to, set up a purpose-built cluster or clusters at a DR location? A lot of different things happened. A lot of disasters happened. People want high performance availability. They want failover, failback, and they realize that they just don't get that with a lot of the legacy approaches. And so being able to use HTTP as a data protocol is very well accepted now, and we really don't have to have that conversation really quite at all.
Excellent. Well, it doesn't look like
very valid. So that's very validating when you had that conversation, for years, and then the world went your way. This is, this part of the overwhelming move towards object storage, and sort of the overwhelming choice of object storage backends, especially for applications at scale.
I couldn't agree more. It doesn't look like there's any other questions. You see Ryan's email address up there? I'm sure he will be happy to respond to any questions that you have via email. You can always also ask your questions to the general info@Caringo email address, and we'll answer them. And with that, I'd just like to thank Ryan for his time. Excellent information. Thank you for your time today, Ryan.
Thanks, Adrian. Thanks, everyone.
And yeah, thank you to the audience. If you have any follow-up questions, just let us know. And that concludes our webinar. Thank you.